Hi, my name is Alan. I am embedded system engineer at Espressif, Brazil. Today, I will explain how I created a natural user interface game running on NuttX RTOS. So, let's start the presentation. First of all, what is natural user interface? Conceptually, it's an invisible interface. That means we don't have some widget or physical button that user will press or will interact. It is more natural. That means that these interfaces are more natural for human beings. Uh, Example of this, we can say gesture, um, also the voice and uh, finger movement like uh, finger pinch to zoom in and zoom out interface. So currently we already use some kind of a natural interface in our normal life. The best example of natural user interface, or maybe the example most remembered, is the 20 years ago movie Minority Report, where Tom Cruise used some kind of infrared LED in his finger to control some kind of big screen, transparent screen, or holographic screen in a way. And he showed all the potential of this kind of interface. As a side note, there is a nice CNN reporter, CNN video about many technologies that Minority Report forecast more than uh, 20 years ago. So, what kind of devices you can use to create natural user interface? Uh, some example, the simplest example is the Nintendo Remote, where you can use it to move, like movie screen, just moving your hand with this controller. Also, the lip motion controller, where you can move your fingers and your hand in the screen and control windows or any kind of interface. Also, the Microsoft Kinetic, uh, it can detect the human body and it can execute anything based on gestures on other features that user or developer decide to create. As I told before, the voice assistant device also can be an example of natural user interface. So when you interact with Alexa, actually you are using natural user interface. Also, the multi-touch screen, when you do zoom in or zoom out, you are also using um, natural user interface. And also for embedded system developers or enthusiasts, there's some low-cost gesture sensors like the APDS 9960 device. This device, I did, I am using this device in this project. Here are the device that I talk about, the remote and lip motion in all these devices. So how the idea started? Uh, Initially, I played with Android game more than 10 years ago called Shift Game. I installed the F-Droid repository to install open source applications, open source apps, and I found this nice game. It's like a mixture of Tetris with Crush Candy and also 2048 game. So in this game, you need to move the blocks to up, to down, to right, to left, and put the blocks with the same color together, and then they will disappear. They will be removed from the board, from the screen. So why to use NuttX instead using Arduino or even some simple RTOS? Why to use NuttX for this project? First of all, NuttX is a POSIX and Linux-like RTOS. That means if I use it, I can create the program using Linux. I can develop the logic and the interface and so on using Linux. And then I will move to NuttX. I just recompile it to NuttX. So NuttX has a video frame buffer, very similar to Linux. Also, it has input device interface, so I can use keyboard, joystick, or any other input device interface, just like Linux. And also, because NuttX already had this gesture sensor integrated on it, so it was easy to validate and to test this application. My initial plans or initial thoughts was just 2 hours is enough to create this game. It's a very simple game. What could be difficult to do it? I didn't look or I didn't analyze the original game source code. So all the game was developed from scratch because I thought it just a very easy game. What could go wrong? So I can do it very easily. At least that was what I was thinking at that time. And the initial idea was, as I told, was to develop it on Linux, to test it without recompile in the firmware and flash the firmware and so on. I just use GCC to compile the C file and run it on Linux. So it was faster than Interact to do it all the time. And the initial idea was to develop it in test mode and then move it to frame buffer or to graphical interface. So idea was to focus on logic instead of focusing on interface or graphical interface. But when I started developing it in the first day, I faced many issues that I didn't imagine before starting it. For example, in the left side we have an example of the initial board game. So all the border of the edge of the matrix has some initial piece or an initial block. This block has a different color, and to identify what is the color, I used number to define it. Very simple. Just use 1 for red, 2 for yellow, 3 for blue, and so on. But when I start to move up, for example, if I press the move up key, it should move up, but it cannot remove the sail. It cannot remove the block that was inside the screen in the matrix originally. So in this example, if I move up, I need to I need to move the floor. For example, the number 2424 for the second floor, and the new floor will get a new values that will behind it, that is hide in another invisible layer, for example, and it cannot remove the sail of the matrix. And the same apply to walls and also to the floor. If I move down, I cannot remove the floor. So it was one of the first challenge to fix. It's not that difficult to fix, but I was surprised when I moved it and didn't realize it will move the block out of the screen initially. Also, the blocks move like some kind of directional gravity applied on it. For example, if the user press the arrows up, the key up, it need to move the blocks to the sail, to the up of the screen. But every time one block hits other or is near the other, it cannot overwrite it. So, for example, this number 1 need to move until it get in the sail in the number 3, but after that, the other number 1 that is two pieces or 2 cells behind it need to move to the next empty cell, and it cannot be overwritten. The other challenge that I have that I didn't go to it, but it's just a number here to say, oh, I have many challenges before get the game done. One of particular was when I start to search for horizontal lines. My initial plans was if I found a horizontal line of the same blocks, I just go there and remove it. How I remove it? I write 0 on it. So 0 is an empty cell. But as you can see here, I face some issues when I did it, because when I remove a line in the second line, that could have some equivalent cell with the same color block. In this case, if I remove the first line, the same color cell in the second line will be in the game board. It will not be removed. So I need to figure out how to fix it. And I came up with simple idea. So instead of removing the value, write 0 it, zeroing it, I just turn it negative. For example, if I want to indicate that number 2 or block, the yellow block, needs to be removed, I turn it negative. So when I do the other test, I will use the absolute value of the cell to compare. So when it tries to find some equivalent cells, it will realize the negative 2 is a valid cell and it's a congruent cell, and we will remove it. And the similar applies to vertical lines. So I did the same to the vertical lines. When I found vertical lines, I invert the signal. Just on detail here, when I search for horizontal line, I start from top and go down. When I search for vertical lines, I swap the matrix in moving in the same column, but navigating for each row by time. And when I finish it, I move to the next column and so on. This way I can find the vertical lines more easily. And finally, I just need to find the triplets, let's say triplets, so there are three adjacent cells with the same block color and squares. So it's very easy. If I am in the first cell, I just verify if the next horizontal cell is the same color, and also in the next row is the same color, and also in the next row and the next column is also the same color. So I validate almost everything, but we are not done yet. That was only one that was missed in the original validation, and I spent some time to realize it, because normally during the test many other numbers or other blocks are removed first. So only I saw something similar to this one that's very clear. The inverted triplet was still in the game board, so I need to remove it. And internal joke, or not so internal, but I decide to make it a little bit more more attractive before moving to the graphic mode. So I decide to replace numbers with the square colored blocks, and the border of the matrix I replace it also to Unicode's grid to make it more easy to see, and more nice to play, more enjoyable. So time to move to NuttX. As expected, it was just a matter of recompile the code, and for my surprise, even the raw keyboard worked nicely. So the term I use that used on Linux to implement the get character to avoid pressing on keyboard and press enter. So I just press the arrow up and down, and it will work very very nice. So the next step after getting the game working in test mode was to create the interface, or integrate interface with the graphical LCD. But my idea was not to use LCD, but instead I was planning to use this RGB APA 102 matrix. Is a standard SPI RGB LEDs. So it's a little bit more expensive than the WS8212, if I'm not wrong with the code. But it is better because I don't need to worry about the times and other signal integrity. It's just standard SPI. It's very easy to use. I don't need to worry about implementing a new interface or new standard. Just for curiosity, this other RGB, the low-cost RGB WS8212, is also supported on NuttX, but I don't like to use this kind of timing to to control the device. I prefer to use standard interface like SPI. So the driver was very straightforward to implement, except it was zigzag. Normally, when you have an LCD screen or LCD display, normally after the end of the first line, it will start from the left to the right. But in this matrix, it is in zigzag because the last LED is connected directly to the near LED in the next line. So I just implemented this zigzag in the source code. I detect the row. If it is even row, I keep the normal buffer direction. If it's odd direction, if it's other row, sorry, I go in inverse direction. So instead of getting the buffer, then the column start from the column 0, I start from the last column and move it to the first column. And here's the LCD interface working. I will show now a small video to show it's running, as you can see here. As you saw, it was very fast, and now we can finally integrate everything. I use the ESP32C3 Rusty board developed by our friend Pedro Minatel. I integrate it with the RGB matrix and with the gesture sensor. Now I will show the demo of it working. Okay, let's start the demonstration. I will run the Shift application. And as you can see, it's a little bit difficult to see the LED colors because the LEDs are too bright. So I create this plastic frame with some paper in the top. Now it's easier to see the blocks. And now I will start playing the game. So if I move up, I put together the red blocks and they are eliminated because we have 3 blocks together. Same here. Moving to the left, I put the green together. Also, another cyan appeared and was removed. If I move down, I put these whites together. And same I can do if I move 2 times, I can eliminate more blocks. For example, these cyan blocks in the right. Move down again. So as you saw, it's a very, very nice, very strategic game. And sometimes it's better not to remove the current block and wait for the next to next move to eliminate more blocks. And also it's very addictive game. So it's really nice to play. And I think it's a nice game to have in some hacker clubs, in maker clubs, maker offices, and so on. And that is it. So let's go back to presentation. As you saw in this demo, it is very interactive and very nice game to play. And I plan to create later some more integrated version with the LEDs and the ESP32C3 in the same board, and everything integrated in product. So these are the conclusion. My initial thought that just 2 hours was enough was totally wrong. I spent about 3 weekends fixing these bugs and getting everything working correctly. And it also proved that NuttX is very Linux-like compatible. So I didn't spend time later porting it to NuttX. It was just compiling and using the right interface on NuttX. The original goal was reached, as you saw. I got everything working as I was initially willing to do. So, thank you very much. I hope you enjoy this presentation, this game. And if you have some questions or other comment, please let me know.